Hello children, in today's class we will be discussing the entire chapter of machine. We are going to cover the all concepts in a single video. Children, in this chapter we have 3 units. In a unit A, mainly we will be discussing about the functions of machine, terms related to the machine, lever, types of lever. Whereas in a unit B, we will be discussing the what is a pulley, types of pulleys, combination of pulleys. In a combination of pulleys, children, we will be discussing about one single fixed pulley with a many movable pulleys and block and tackle system. Children, if you need a in detail discussion on this machines chapter, links will be given in the description. Just go through them so that you will have there each and every topic is discussed in detail. So now let us see, children. First of all, what do you think about machine, children? Generally, whenever we can think about machine, what are the things which will come to our mind? So the simple thing is that actually, children, what is the purpose of machine here? We all know very well that machine will make our work easy and it saves our time. Yes or no? Yes. But thing is that some extent it is okay, children. So we should not depend much on the machines. Otherwise, what will happen, if completely we are depending on the machine, so many issues we have to face. Yes, plus point is there as well as minus point is there. We have to use the machine. It doesn't mean that completely without machine we cannot live. No, it should not be like that. Okay, na? Fine, children. So in a simple terms, a machine is a device which makes our work easy and saves our time actually. Okay, now fine. And what are the functions of the machine, children? Of course, we have many functions of machine actually, but we can classify all these functions into 4 points actually. So the first one is that, children, so every machine, not like every machine, in general, machines can act like a force multipliers. First, let us see. So machines can act like a force multipliers. So what is meant by force multiplier, children? So in a 9th class, we learned about hydraulic machine. Let me tell you. So hydraulic machine will be like this. So this is actually hydraulic machine. So here is a piston of smaller cross section. Smaller cross section. It is a piston with a bit larger cross section. So here let us say force F1. For suppose here 10 Newton force is applied on this area of cross section of, let us say, 5 centimeter square. Just example I am telling you. Example we are taking. Okay now. And let us say here is the area of cross section. This one is, let us say, it is a 100 centimeter square. Now thing is that what is the force exerted on the larger piston? So here we have this formula, right? That is F1 by A1 is equal to F2 by A2. So we need to calculate F2. So here F2 is equal, children, that is F1 by A1 into it is A2. That is F1 is how much? 10 by 5 into 100. So 5 ones are here 520. So here we got 200 Newton, children. 200 Newton. Which means what? Just we applied 10 Newton, but as a result, we are getting 200 Newton. Which means what? The whatever the force which we are giving to that machine, it is multiplied. That's what we can say that hydraulic machines can act like a force multipliers. Even, children, the jack which is used to lift the vehicles is also comes under force multiplier only. So the one of the important function of the machine is what, children? Machine can act like a force multiplier. Is it clear? Fine. Now let us see a second function. This is a force multiplier is the first one. So let us see a second one, children. So machine also can act like a speed multiplier. Speed multiplier, which means what? There will be a gain in speed. There will be a gain in speed. If you can see any, nowadays if you can see any vehicle, generally whenever we wanna, buy a vehicle, children, what do? Generally, we will see what is the speed gained actually, with what speed that particular vehicle will go. Vehicle means what, children? It is also machine only. But to understand this, simple example let us take. That is scissors. Children, here scissors means we have many types of scissors. Here I am going to take a scissor which has long blade. Generally it is used to cut the cloths. So this is, let us say, these are the blades. Let us say it is a handle. So here is this one. Fine, children. So this is a place where actually we put that so called cloth or something. Okay, let us say it is a cloth we put. Children, if you can see, this is handle. This one it's a handle. Okay, right. These are the blades. These are the blades. So children, it's very clear that, very clear. So blades are longer than handle. First point we need to remember, blades are longer than handle. And children, in a given time, the moment when you try to move this handle, obviously blades also will move. But the thing is that what we will notice is that blades will move longer than handle. I mean what? Distance covered by the blade, that is distance covered by the blade, right? Let us say distance covered by the blade is greater than the distance covered by the handle. Distance covered by the handle in a given time, same time. I mean what here? Time is same. Time is same. So this distance by time is what? Actually speed. So which means what? The speed of the blade is greater than the speed of the handle. Hence there is a gain in speed. Okay children. So that is the reason how, that is the reason why our machines are used as a speed multiplier. So first one is what? Machines are used as a force multipliers. And second one is machines are used as a speed multipliers. Is that clear? Fine. Now let us take a third one. What is the third function children here? Machines here, machines they are used to change the direction of effort applied, to change the direction of effort applied, Children, for this let us take a simple example, so called single fixed pulley. Children, here let us take, here is a rigid support. So here is single fixed pulley. Anyhow, regarding single fixed pulley in detail we'll discuss. Just wait a few minutes. Okay, fine. So here is a rope which is passing over the pulley, and let us say so called, okay, here is some bucket or anything load, whatever you put. This is a effort. Children, in general, if you can notice a single fixed pulley, we apply the effort downward direction. But in which direction load will move? Load is moving upward direction. Generally, children, we learnt in a chapter 1, but we all know very well that also. What is that? Whenever you apply force, in general, bodies will be displaced in the direction only. But here what is happening? We are applying the effort downward direction, but body is, that is the load is lifted vertically upward direction, as if effort is acting upward direction. We are exerting the effort downward only. But this single fixed pulley, so called machine, is changing the direction of effort applied. Is that clear? So what is the third function, children? The third function is to change the direction of effort applied. Is that clear? Fine. Fine. Now we see the fourth function, children. So the fourth function is to change the point of application of effort, to convenient point, to a convenient point. I mean what actually, we want to apply the effort. Actually, we want effort to be exerted at a point B, but we cannot apply at a point B. Let us say, for example, here let us say it is a machine, let us something more. Actually, it is a point B where we want to apply the where we want to exert the effort at this point, but think that it is not comfortable to us. Then what we'll do? We apply some other point. We apply the effort some other point, and whatever the effort which we are applying at this point will be shifted to this, actually will be shifted to the convenient point. Okay, so to change the point of application of effort to a convenient point. Then what is the best example? Yes, children, just wait. We will take a best example to understand in a best manner. Okay, fine. So here, yes, look at here. So again, I need to show my drawing skill. Just bear me. Okay, now. So children, let us say here is. Can you guess whatever I am going to make? So don't say simple circles. Hey, you don't believe that. Look at here. We are going to get the best diagram. Okay, now. So just here. Look at here, children. So let me try my level best. Okay, now. Okay, so here something I want like this. Okay, able to understand what I'm trying to. Okay, something like this. So somewhat, is it looking like a cycle, bicycle? Please can adjust. Okay, na? Yes. So children, see, so diagram is not important. Actually, what is the point? What we are going to learn is very important. Okay, fine. Children, this unit is a rear wheel actually. It's a front wheel actually. To make the cycle to move actually, we have to move the cycle, means rear wheel actually should be moved actually. But children, just imagine, here you are sitting, just you think here you are sitting, okay na? But how can you exert effort or a force on this rear wheel, children? Is it comfortable to us? Just imagine, oh my god. So imagine it's just too difficult to us to exert the effort at this point. For that only, we will exert effort here actually. Then this is a point where we are applying the effort, but that to be transferred, that to be changed to the convenient point. So for that only, children, for that only, what we have here, we have chain system, So whatever the effort we are applying on this pedal, it is shifted, it is changed to the rear wheel, so called convenient point. We are applying the effort here only, but that point of application effort is shifted to the rear wheel, so that rear will be moved, so that what will happen, our bicycle will move forward direction. Is that clear, children? Fine. So these are the 4. Children, again I am telling you, whatever the example which I am giving, it is not compulsory that you should take these examples to understand. No, it's not that. Just you can observe in your premises, in your surroundings, whatever the example which you have, whatever the machine which you feel, just try to understand what is its output. Children, based on the output only, we will decide its function. It's very important. So here we have main 4 important functions. First one is what? Machine acts like a force multiplier, machine acts like a speed multiplier, machine is used to change the direction of effort applied, and the 4th one is what? It is used to change the point of application of effort to a convenient point. Just you copy it. Now children, we discussed the terms related, very important. So here, terms related to the machine, Are you able to see this? Let me check once. Terms, yes, terms relate to the machine. Children, for suppose, let us take it is a machine. Let us say it is a machine. M for machine. Children, to understand this, what is my suggestion is that kindly just recall about what is this electric crane which can lift the vehicles. Sorry, no, okay, it can lift the vehicles also, which can lift the what you can say heavy weights. So just imagine that, take that example to your mind, then listen this, 100% you can understand that. Is that clear? Fine. So let us say it's the electric crane, let us say, children. So here, somewhere here, some weights will be there, heavy weights will be there, General children, so in order to make the machine to lift this actually, what we have to do? Generally, the driver will be there. Don't you think he exerts some force? Where he is exerting force? He exerts the force on the machine. Is that clear? To make the machine to work actually, some force must be exerted on it. Is that clear? Yes. So children, whatever the force which we are applying on the machine is called effort. So effort is a technical term. Children, effort is force only, but the special technical term which we are using in the case of machines. So what is the effort, children? The force which we are applying on the machine is called what actually is the effort. Very important, effort. So we can use the symbols. Fine, children. As a result, what will happen? This machine will try to lift this. This machine will try to lift this. But as a machine is trying to lift these weights, do you think that the weight will be feeling very happy? Yes, machine, just lift me. I will be coming up like that. Will be telling her, please lift me. No, it's not like that. Due to the gravity, it will try to go down. Which means what? It will try to resist. Means it also exerts some force downward direction. Yes or no? Yes. Means this machine should overcome this resistive force, so called load. Yes or no? So the technical term given to this is what children? It's a load. So load is nothing but what children? It's a resistive force. It is what? Resistive force. Am I clear? Is it clear? Let me tell you once again. Children, what is load actually? It's very important. Make note of it. What is the load, children, here? The resistive force to be overcome by the machine is called load. So we can use the symbol L. Then what is effort? The force applied on the machine to overcome the resistive force is called effort. Okay, na? So here two terms, very important terms which we learned. The first one is what, children? The first one is effort. The first one is effort. Symbol can be used, effort. Second one is what actually? It is a load. Symbol can be used. Children, either it is effort or load, both are nothing but the force only. What is the unit of effort? Newton. What is the unit of load? It is also Newton only. Can I erase this? Yes. Now, one more important term, third one we will be learning, that is mechanical advantage. Children, these terms are very important to understand the concepts of machine. Okay, now? So, mechanical advantage. So, advantage. Children, this seems to be very lengthy, but definition is very easy. Children, here this shortcut MA is accepted. MA is what? Not a master of arts, not a martial arts. So, it is mechanical advantage. Children, here mechanical advantage is defined as a ratio between load and effort. Children, the ratio between load and effort is called mechanical advantage. So, it can be MA is equal to load by effort. Children, what are the units of mechanical advantage? Children, as I told you that load is measured in Newton only, effort also measured in Newton only. So, both will get cancelled, which means what here? Mechanical advantage has no unit. Mechanical advantage has no unit. Okay, fine. And here we have three cases. Examination point of view, it's very important. The first one, children, look at it. If load is greater than effort, what will happen, children? If load is greater than effort, here mechanical advantage will be greater than 1. For any machine, mechanical advantage is greater than 1. It acts like a force multiplier. It acts like a force multiplier. Very important. Okay, fine. Whereas, second case, if load is less than effort, children, then what will happen? Mechanical advantage will be less than 1. So, then it acts like a speed multiplier. It acts like a speed multiplier. Whereas, children, what if load is equal to effort? What if load is equal to effort? Obviously, here mechanical advantage is equal to 1. Then what will happen? Such a machine is used to change the direction of effort applied. Is that clear? If a mechanical advantage is equal to 1, it is used to change the direction of effort applied. Okay, just copy this so that we can go for next technical term. Okay, is it copied? 3, 2, 1. Yes. Yes. Now, let us discuss the fourth term, that is called velocity ratio. Velocity ratio. So, we can call it as a VR. Children, this is very important. Whenever you are exerting a force at a point, so called effort, that point will be displaced. Means that point will go with a certain, what we can say, velocity. For example, children, let us recall example telling, let us recall the single fixed pulley only. So, this is a point where we are helping the effort downward direction, and this is a load. Okay, it will be moving upward direction. Don't you think that as you are pulling it, it will be moving downward with certain speed? Yes, means effort has some speed. Simultaneously, load also will be moving upward direction with a certain speed. So, there will be a speed for effort, speed for load. So, children, here velocity ratio is defined as the ratio between effort speed to the load speed. Very, very important. It is the ratio of effort speed to the load speed, or effort velocity to the load velocity. But children, we know that velocity is equal to, what we know, it's a displacement by time. Okay, na? So, it can be written as effort displacement by time to the load displacement by time. Here anyhow time will get cancelled, so it is also defined as, velocity ratio is also defined as effort displacement to the load displacement, but in a given time, children. So that's what my advice is, that whenever it is asked you to define a velocity ratio, better go for this definition, that is ratio of what we can say effort velocity to the load velocity. If you want to write this, you can write, but how to write effort displacement to the load displacement in a given time. Okay, fine. And if you can see here also, children, so either it's velocity, displacement, which means what? Velocity ratio also, it is a ratio between same two similar physical quantities, so that their units will get cancelled. So hence, what we can say, it also has no unit. It also has no unit. Is it clear? Fine. And here also, children, we have three cases. Let us see. So the first case here. So what happens if, children, effort velocity is greater than the load velocity? Obviously, what will happen, children? Velocity ratio will be greater than 1. So if effort velocity is less than the load velocity, so velocity ratio will be less than 1. Whereas if effort velocity is equal to load velocity, then velocity ratio is equal to 1. Dear children, if for any machine, if velocity ratio is greater than 1, what will happen? It acts like a force multiplier. Whereas if velocity ratio is less than 1, it acts like a speed multiplier. Whereas if velocity ratio is equal to 1, it is used to change the direction of effort applied. Is that clear? Fine, just you copy it. Copy it? Is it copied, children? Fine, yes. Now, the next technical term which we will be learning is efficiency. Children, it's very important. Whenever we talk about the machine, so we will see actually its efficiency. We'll see its efficiency. Efficiency, the symbol is used as eta. So children, for example, let us say here is a machine. So as we are applying force on the machine, so called effort. Okay, we are applying the effort. Okay, which means what? We are doing some work on the machine. As a result, what will happen here? Machine also exerting some force on the load. Yes, sir. So as we are exerting effort on the machine, means what? We are doing some work. So called it's a work input. Whatever we are doing the work on the machine is called work input. As a result, machine does some work on the load called work output. So how can we define efficiency, children? Efficiency is defined as the work output. It is the ratio between work output to the work input. So in general, efficiency is expressed in terms of percentage. So here efficiency percentage is equal to work output by work input into 100. Is that clear, children? Fine. So these are the very important terms related to the machine. Clear? Fine, children. Now what is the principle of machine, children? In ideal case, let us talk. Mostly, children, in this chapter, 99% we will be talking about the ideal cases. So practical cases are very less. So children, in an ideal case, what we discuss, so whatever the work which we are doing, we expect that same work will be obtained. I mean what? We expect that work output is equal to the work input. Which means what? Whatever the input energy which we are giving, for example, 10 joules of input energy we are giving, and we think that the energy is not getting wasted and we will get output as a same amount of energy. So principle of machine says that in an ideal condition, in an ideal case, input energy is always equal to the output energy. Is that clear? Fine. Now children, we discuss the very important thing, that is what actually the relation between efficiency, mechanical advantage and what? Velocity ratio. That is relation between, let me write here. Fine, children. Children, as per the definition of efficiency, so efficiency is defined as work output to the work input. But children, we know that actually work is equal to what? It is force into displacement. Force into displacement. But how to calculate work output, children? Work output, and we need to calculate work input also. Work input means what? The force which we are applying in the machine, so called effort. So we should take effort into effort displacement. Work output means what actually? It will be load into load displacement. Is that clear? Just you substitute here. So work output is equal to load into load displacement by effort into effort displacement, that is effort displacement. Now can we rewrite like this, children? That is load by effort. Just we are not in a individual, we are writing load displacement by effort displacement. So for sake of our convenience, children, it can be written as load by effort into 1 by effort displacement by load displacement. Children, we know already that mechanical advantage is equal to load by effort. Velocity ratio is equal to effort displacement by load displacement. So here we can substitute efficiency is equal to mechanical advantage by velocity ratio. Children, very important relation. Or we also can write mechanical advantage is equal to efficiency into velocity ratio. So if you want to express in terms of percentage, this can be written as efficiency percentage is equal to mechanical advantage by velocity ratio into 100. So this is the relation between efficiency, mechanical advantage and velocity ratio. Just to copy this, children. Now we discuss the types of machine. Okay, just copy it. Fine, children. Now, so here ideal machine, children, practically it is not possible. Only in our assumption it is possible. I can say it's type of a dream machine. Okay, children, fine. So the ideal machine, so in which what will happen, you know, work output, that is work input, is always equal to the work output. Means what? There is no energy wastage. That's what work output is always equal to the work input. Okay, fine. Now, children, so the very important thing is that we know that efficiency is equal to work input by So here, sorry, it's efficiency is equal to work output by work input, work output. As these both are equal, children, will get cancelled. Then for ideal machine, n is equal to 1 or it is 100%. Very important. And here they will, in exam they will ask like this: for ideal machine, how mechanical advantage and velocity ratio are related? Children, from the relation just which we discussed, efficiency is equal to mechanical advantage by velocity ratio. But this efficiency value is 1. As mechanical advantage by velocity ratio is equal to 1, children, how these two are related? Mechanical advantage is equal to velocity ratio. So these are the 3 points which we need to remember for ideal machine. Now let us think for a actual machine, children. So for actual machine, children, here work output is always less than work input. In exam they will ask why? Because of many reasons are there, but important 2 reasons let us recall. Just because of friction and weights of parts of the machine. So weights of parts means, children, means machine has to overcome even its own weight also. So we know that, children, that what we can say, electric crane will be lifting the load let us say 100 kgf. But don't you think that electric crane hand will be there? It is also metal, it also has some weight, right? Means that machine even has to overcome its own weight. For that some input energy is spent. So that output energy can never be equal to the input energy. Am I clear? So to overcome the friction and to overcome the weights of the parts of the machine, some amount of energy must be spent. That's what work output is always less than the work input. Okay, fine, children. As a work output is always less than the work input, children, means if you can see, that is numerator is always less than the denominator. Numerator is always less than the denominator, then obviously efficiency is less than 1 or efficiency is less than 100%. Then for actual machine, so-called practical machine, how a mechanical advantage is related to the velocity ratio. Children, here, so from the definition of here, efficiency is equal to mechanical advantage by, it is velocity ratio. But here efficiency is less than 1, right? So obviously what will happen, mechanical advantage is always less than velocity ratio. Always less than velocity ratio. This is a very important. Is that clear? Mainly this, children. For actual machine, mechanical advantage is equal to velocity ratio for an ideal machine. Whereas for actual machine, mechanical advantage is always less than velocity ratio. Is that clear, children? Fine. So these are the important terms and the types of machines. Now we'll discuss what is a lever and types of levers. So now we will be discussing about a lever. Children, it is not a lever. Okay, now it's not a lever. It is a lever. Children, I will tell you one important mantra. You remember, so that all types of levers you can remember easily. What is that? Lever is my flower. Lever is my flower. Lever is my flower. Lever is my flower. So just you know recite like a rhyme. Lever, lever, you are my flower. Can you say once again? Lever, lever, you are my flower. Okay, that's fine. I'll tell you what is a plus point by remembering this. Easily we can remember the types of levers, children. Yes, seems to be funny, but really we can remember all class levers without any confusion. First of all, what is a lever, children? See, a lever, it is it's a rigid. It can be a bent or a straight bar, which is capable of turning about a fixed axis. First, here we discuss about the principle of lever. Children, it's very important. First, let us discuss the principle of lever. Principle of lever. Children, here lever works on the principle of moments. Principle of moments, which we discussed in where? In chapter 1 force actually. Just recall that actually. So what was that actually, children? So there, this is F1, this is F2, this distance is R1, this distance R2, this is a pivot point. So in a equilibrium condition, F1 into R1 is equal to F2 into R2. This is what actually we discussed. Children, this is a principle of movement, but based on this only, lever also will work. Let us see how. So children, let us take here is a lever, which means what? A rigid straight bar I am taking. It can be bent also. Let us say it is capable of rotate about this axis. Let us imagine. This only we can call it as a fulcrum, children. It is a fulcrum. Fulcrum, we will use letter F. Okay, so for example, this side some load is placed. This side some load is placed. Then a load is a load. Then to overcome this load, we need to apply some effort. We need to apply some effort. Here symbols can be used, children. Effort. Let us say it's a E. It is a load. Okay, children. Fine. Let us say it is a F. This say it's a L. It is, children. Here to here we can call it the effort arm, which means what? The distance between fulcrum and a point of application of effort is called effort arm. Then what is the load arm? The distance between fulcrum to the point of application of load is called load arm. We can use the symbols also. So this is, we can call it as a effort arm, and this is called actually load arm. So as per the principle of moments, children, it can be written as effort in equilibrium, effort into effort arm is equal to load into load arm. Now let us simplify. Let us take effort this side, load arm this side. So load by effort is equal to effort arm by what we can say, load arm. But children, load by effort is what actually? Mechanical advantage. So here mechanical advantage is equal to effort arm by load arm. Children, this is a formula which we use to calculate the mechanical advantage of the lever. So what is the mechanical advantage of the lever formula, children? Mechanical advantage is equal to effort arm by load arm. What is the effort arm, children? The distance between fulcrum to the point of application of effort. What is the load arm? The distance between fulcrum to the point of application of load. Is that clear? Fine. Now we discuss the types of levers. Fine. Children, here, so levers are classified into three classes, three groups actually. But based on what? Children, based on relative positions of effort, load, fulcrum, means the point where load is acting, effort is acting, and where this fulcrum is placed. Based on that only, levers are classified into three categories. So first one is class 1 levers. Now we will see class 1 levers. Children, For a class, see children, as I told you that based on the relative positions of load, effort, fulcrum only we can classify, we can categorize into class 1, class 2, class 3 levers. For a class 1 lever, children, fulcrum is in middle and either of side load and effort can be. Left side you can put load or right side you can put a load. It's not a matter actually. But in middle what? Fulcrum must be there. So this is how, let us say it's that rigid bar. Let us say this is the fulcrum. So let us say this side is load is there. So obviously this side will be effort will be there. Is it clear, children? So such type of levers comes under class 1 levers. Now here we have 3 special cases. Let us see, children. Here the first one, children. For suppose if the fulcrum is in exactly middle, then what will happen? Effort arm will be equal to the load arm. Am I clear? Yes. So here effort arm is equal to the load arm. So then mechanical advantage is equal to how much then, children? If effort arm is equal to load arm, then what will happen? Both will get cancelled. Then mechanical advantage is equal to 1. Clear? Fine. Now children, let us do one more thing. If this fulcrum, for suppose, if it is shifted towards the load, then what will happen? Effort arm will be increased. Effort arm will be greater. So if effort arm is greater than the load arm, children, then what will happen? Mechanical advantage is greater than 1. If not, for suppose this fulcrum is shifted towards effort, then what will happen? Load arm will be increased. So third one, if load arm will be greater than the effort arm or effort arm will be less than the load arm, then what will happen? Mechanical advantage will be less than 1. Children, this is a very important conclusion which we got. For a class 1 levers, mechanical advantage can be equal to 1, can be greater than 1, can be less than 1. Children, if mechanical advantage is equal to 1, they are, they act like they are used to change the direction of effort applied. The best example, single fixed pulley you can take. Okay, that you leave it, single fixed pulley. Next we'll discuss another pulley. So here, the best example, let us take a seesaw, children, here. So here, seesaw will be the best example for this mechanical advantage where it is equal to 1. If mechanical advantage is greater than 1, children, so for this, what is the best example to say class 1 levers whose mechanical is greater than 1? So here we can say it's a crowbar, children. Crowbar will be there. So how the crowbar will be there? So crowbar will be like this. So this how actually, children, it is not a hockey stick, okay na? Will be little bit like this. Here stone will be there. Okay, there is a load which has to be lifted and here is a effort we will apply. This point act like a fulcrum. So now here effort arm will be greater than the load arm actually, so that we can lift the heavy loads by applying the less effort. So this is the best example of class 1 lever whose mechanical advantage is greater than 1. Okay, fine. And here class 1 lever whose mechanical advantage is less than 1 is what actually? It's what we can scissors, children. Scissors which are used to cut the cloth, children. So look at here. So this point is a fulcrum. This is a point where we apply the effort. So here that load will be there. The cloth whatever we want to cut is the load actually. So this will be the load arm and this will be the effort arm. So if you can see here, load arm is greater than the effort arm. Children, the beauty of class 1 levers is that class 1 levers are all-rounders. Class 1 levers are all-rounders, which means what? They are used as a force multipliers, they are used as speed multipliers, they are used to change the direction of effort applied. Is that clear? Just copy it. Now we'll discuss the class 2 levers. Is it copied? 3, 2, 1. Yes. So now we see the class 2 levers, children. We see the class 2 levers. So children, here for a class 2 levers, if you can see, children, here, so in middle load will be there, so that either of side effort and fulcrum will be there. Children, here you have to remember load. So for a class 2 levers, load will be arranged in a middle, so that either of side effort and fulcrum will be there. Okay, fine. Children, load you can shift either towards fulcrum or towards effort, let us say, but still this is effort arm, this is effort arm and this will be load arm. So you can change the load position, but it can never be, that is load arm can never be greater than the effort arm, which means what here? Always, children, it's very, very important. It is always effort arm is greater than the load arm. Which means what? As effort arm is greater than load arm always, mechanical advantage is always greater than 1. Which means what here? Class 2 levers always acts like a force multipliers. Very important. Means these are like a bahubalis. Class 1 lever in sometimes it behaves like a bahubali, but whereas class 2 lever always acts like a bahubali. I mean what? It's like a force multiplier. Why? Class 2 levers always acts as a force multipliers because effort arm is always greater than the load arm. Let us see the best example to understand, children. So let us see the nutcracker. Let us see the nutcracker will be there. Nutcracker is the best example to understand this here. So how the nutcracker will be? Again, let me show my drawing skills. I don't run anywhere. Just you have to bear me. I said no? Yes. So somewhat like this. Don't get doubt that I'm drawing a fish or something. No, it seems to be like this. I'm not sure. Okay. This is a point where I place a nut. That nut to be broken. Okay, children. This is what actually fulcrum. This is a point where we apply the effort actually. This is load here. So you can see here, this is effort arm, this is load arm. That's it. So effort arm is always greater than load arm. That is the reason why easy manner we can break that nut. Even lemon squeezer, even bottle opener, this all comes under what? Class 2 lever. So for a class 2 levers, load will be in middle, children, and a mechanical advantage is greater than 1. They are acting always like a force multipliers. Clear? Fine. Now we see class 3 levers. We see class 3 levers. Class 3 levers. So for a class 3 levers, children, here effort will be in middle so that either of side fulcrum and load will be there. Fulcrum load. And if you can see, this will be the load arm and this will be the effort arm. This will be the effort arm. So which means what? You can change the position of effort, but you can't put beyond load actually. So which means what? You can't make effort arm greater than the load arm. Which means what? Always, it's very important. Always effort arm is less than the load arm. So which means what here? Mechanical advantage is always less than the 1. Which means class 3 levers always acts like a speed multipliers. Speed multipliers. Is that clear? So children, the best example for this. So you might have noticed, you might be knowing actually. So I'm not that much, I don't have that much good knowledge in sports. But recently I have seen a video. I think it is like, it's sports. I think related to the Kerala state, if I'm not wrong. I don't know if any corrections are there, or if you know very well, you can mention a comment box regarding that sports actually. There one board will be there, long board will be there. There 10 persons are sitting one side, another persons are sitting in 10 whatever, another side actually, 10 more persons actually. It's a competition between boards actually. But there one person won't actually apply there actually. Here there almost 20 persons will run that boat actually. Which means what? There they'll be holding the stick actually. In middle they'll hold like this. Okay na. So that will be there moving very fast like this they are doing. Which means what here? This point where it is able to move, this acts like a fulcrum. And middle they are applying the effort. And the water will be there, that is a load. So effort is in middle, this is a load, and it is a fulcrum. Best example for what actually? Speed multipliers. If you want, okay, here what we can say, sugar tongue will be there. Fire tongue or sugar tongue. So here with that we will be holding, it is a load actually. This acts like a fulcrum. This is a place where we apply the effort. Is it clear? So that here load arm will be always greater than the effort arm. So that mechanical advantage will be less than 1. So they act like a speed multipliers. Okay children, and a few more examples I will try to show you on screen. Just kindly copy those examples. Children, as many as examples you can, just try to gather, try to understand, try to learn, try to remember. Examination point of view, it's very important. So with this we completed the lever concept. Now we start a pulley concept. Children, now let us see what is this lever is my flower. Children, so let me write like this, flower F L O W E R, flower. Can you write like this? Yes, capital, small, that you leave it. Leave it. Let us see how are we going to remember the all class levers in easy manner. Okay children, so this one is what actually class 1 lever, this is what actually class 2 lever, this is what actually class 3 levers. Means what children? In a class 1 levers, fulcrum is in middle. In a class 2 levers, load is in middle. In a class 3 levers, effort is in middle. So if you can remember if we know what is there in middle, obviously you can understand other two sides easily. So that's what I said, lever is my flower. If you can remember a flower word in order, you can remember children. In order, class 1 lever, fulcrum is in middle. Class 2 lever, load is in middle. Class 3 lever, effort is in middle. Okay children, see if you think that it is a useful, you can use it. If you think that you have a better idea, yes, go ahead. Okay children, just copy it. It will be like it will be there in notebook. Whenever it is needed, you can use it, right? Just take this. So now we discuss about actually pulley, types of pulleys. There we'll discuss the combination of pulleys. Children, what is a pulley? In a simple manner, we can say that pulley is it's a disc, might be made up of with wood or metal, and which has a grooved edge. Like this it will be there, so that what will happen, a string or a rope can pass over it actually. Is that clear? And it has its own axis of rotation about which it can be rotated. Is that clear? Fine. And here we have two types of pulleys. First we discuss about single fixed pulley children, and here for each what we can say, for each pulley, so we will calculate what is its mechanical advantage and what is its velocity ratio. Finally we will discuss its efficiency also. So first of all, why we are calling it as a fixed pulley, let us see. So if you can think about the diagram, then you can easily understand. Children, when you can go to the villages, there they'll be taking water from the well. There actually this pulley you can see. Okay, so here let me write like this, let me make like this, so that you also can understand very easily. Have you seen this kind of thing? Yes. Children, if you can apply so when you apply the effort downward direction, this load will be moving upward direction. And here if you can notice, this pulley will be rotating like this, but about which it will rotate, it will be rotating about its axis of rotation. Means this axis of rotation won't move up and down, only the pulley will be rotating. Means what? Axis of rotation is fixed children. This is a very important point to understand. Means for a single fixed pulley, the first point is actually very important. It's axis of rotation. Axis of rotation is not movable. Axis of rotation is not movable, or also you can say its axis of rotation is fixed. Okay, fine. And one more important point children, as effort is coming downward direction, load will be moving upward direction. Okay, fine. And one more thing, if effort will move children by x x displacement, effort has x displacement, here load also will have x displacement only, which means what children, effort displacement is equal to load displacement. So I can write like this. So here effort displacement is equal to load displacement, but minus I will put. Why I am putting minus children? Because both are in opposite direction. As effort is coming downward direction, load will be moving upward direction, but both magnitude is same but direction is different. Okay, fine. And one more thing children, already we have learnt in a class 9th. So whenever our bodies are suspended by means of a string, a kind of force will come into play, so called tension. Here also tension will come into play. So here effort is acting downward direction, here tension will be acting upward direction, and here also will be acting upward direction. Children, here we consider the ideal string. Ideal string means what? It's inelastic, it's a massless, and we also consider the frictionless pulley. Children, for in detail discussion about this pulleys and machines chapter, just kindly go to the description. There I gave a links where each and every topic is discussed in detail. Okay children, fine. So this is what actually the information regarding single fixed pulley. Now let us calculate its mechanical advantage, and we can calculate its velocity ratio. So first let us calculate mechanical advantage. So we know mechanical advantage is equal to load by effort. But in equilibrium, it's very important. So effort is balanced by tension, load is balanced by tension. And in exam they may ask question like this also. How effort and load are related in the case of single fixed pulley? Effort is equal to load. Effort is equal to load. So here we will get, this is tension by tension. Both will get cancelled. So here mechanical advantage is equal to 1. So mechanical advantage of single fixed pulley is 1. Now let us calculate the velocity ratio. Children, velocity ratio is equal to effort displacement by load displacement. And just so we have seen, effort displacement is equal to load displacement. If effort displacement is x, load displacement is x, both will get cancelled. So velocity ratio is equal to 1. So now we calculate mechanical advantage and velocity ratio. Now let us calculate the efficiency. So the third one is what actually? Efficiency. Efficiency is equal to mechanical advantage by velocity ratio. Here we got 1 by 1. So efficiency is equal to 1, or we got 100%. Okay children. So here mechanical advantage is equal to 1, velocity ratio is equal to 1, which means what here? Single fixed pulley is used to change the direction of effort applied. Is that clear? Just copy it. Now we discuss the single mobile pulley. Single mobile pulley children. So now let us see here. So if we can make a diagram, it will be very easy to us to understand. So let us say here is pulley. Okay, this is the rope which is passing over it, and this is one. Here is load will be. Load will be. Fine children. Now this is a point where we apply the effort, so that here is a tension, it is a tension, and load always will act downward. It may be displaced up, but it always acts in downward direction, because it is nothing but a resistive force will be acting always downward direction only. Fine children. Why we are calling it as a movable pulley? Because this is a axis of rotation. As you are applying the effort vertical upward direction children, see this axis of rotation, see that pulley will be rotating simultaneously. This axis of rotation also moving. If you want up and down it will be moving. Means what here? First point, its axis of rotation. Its axis of rotation. Its axis of rotation is not fixed, or simply we can say it is movable. The axis of rotation is movable it is. And one important thing is that children, here you are applying the effort upward direction, load also moving upward direction, which means what? Effort displacement, load displacement, means both are in the same direction. Displacement of effort, displacement of load will be in the same direction. Clear? Fine children. And here if you can see children, here effort is balanced by tension, that is okay. Effort is balanced by tension. But if you can notice children, here this load is balanced by these two tensions developed in these two segments of the strings. These two tensions are balancing this load, means L is equal to T plus T. It's very important. That is, load is equal to 2T. So this also we can write L is equal to 2E. So this is how load and effort for single movable pulley, they are related. Now let us come to the displacement children. For suppose children, here if this load is lifted like this up by X, then what will happen? Each segment of the string will be loosened by X. This is X, this is X. Then what will happen? This load will move up by 2X. Means what? Displacement of effort is double than that of the displacement of the load. It's a very important point. So which means what? Effort displacement is equal to the twice the displacement of load, or displacement of load is equal to half of the effort displacement. Okay, fine. Now let us calculate the mechanical advantage. Children, here mechanical advantage is equal to load by effort. But here load, we know what is that here? Load is 2 times of effort, that is 2E by E. E gets cancelled. So here mechanical advantage of the single movable pulley is greater than 1, that is 2. Of course, it is 2 only. But can we say it's greater than 1? Yes, we can say that. Okay, fine. Now let us calculate the velocity ratio children. So here velocity ratio is equal to effort displacement by load displacement. Children, if effort displacement is X, load displacement is half of its value. Half of its value. So X gets cancelled, then velocity ratio is equal to 2. So mechanical advantage and velocity ratio is equal to 2. Now let us calculate the efficiency, children, here. So here efficiency is equal to this third one to be calculated is efficiency is equal to mechanical advantage by velocity ratio. This is 2 by 2, both will get cancelled. So efficiency is equal to 1 or 100%. Children, did you notice one thing? Even for a single fixed pulley also we got 1 or 100%, which means what? These are ideal pulleys, not actual pulleys. For actual pulleys, efficiency is always less than 100%, but these are ideal pulleys. Children, for a single movable pulley, as a mechanical advantage is equal to velocity is equal to, which means what? Greater than 1. So for any machine, if mechanical advantage or velocity ratio is greater than 1, how they will act? They will act like a Bahubali. Bahubali means what, children, here? Force multiplier. They will act like a force multipliers. Is that clear? Fine. Of course, children. So you apply less effort, you may gain more effort. That is fine. But there is one problem with single movable pulley. What is that problem? We have to apply the effort vertical upward direction. Children, you tell me, you think once, applying the effort downward is easier or applying the effort vertically upward is easier? So it's very clear that we need to apply the effort vertically downward direction, so that it's very comfortable to us. But if you can see a single movable pulley, we need to offer the effort vertically upward direction. This is a problem. But how can we overcome this problem, children? We can overcome this problem by combining, means by combining single movable pulley with a single fixed pulley. Then you may get one doubt. Sir, if we combine single movable pulley with a single fixed pulley, is there any change in the mechanical advantage or velocity ratio or its application? Let us see what will happen when a single movable pulley is connected with the single fixed pulley. Let us see the situation, what is going to happen. Just to copy this, now we see that. Yes, so this is how it will be there. Children, let us name it as A and B. Children, what is A and what is B? A is a single fixed pulley, B is a single movable pulley. So now this is a point where we apply the effort. Children, load direction is always downward direction only. And here tension will act upward direction, here tension will act upward direction, here tension will act upward direction. Now children, here let us see, in a equilibrium condition what will happen? Effort is balanced by tension, and here load is balanced by these tensions developed in the two segments of the strings actually, which means what here? So here load is balanced by 2T. Okay, that's fine. So with this we can calculate a mechanical advantage. Let us see here. So mechanical advantage is equal to, we know it is a load by effort. So load is 2T, effort is T. T get cancelled. So here mechanical advantage is equal to 2 only. That is fine. Now children, for suppose if this load is lifted by X displacement, then what will happen? Each segment of the string is loosened by X. This is X, this X. As a result, this effort will come by 2X, which means what here? Effort displacement is 2X if load displacement is a X. Okay, fine. Now, what is the velocity ratio? Velocity ratio is equal to effort displacement by load displacement. This is 2X by X. X cancel. So here is velocity ratio is equal to 2 it is. Now let us calculate the mechanical advantage, children. So here mechanical advantage is equal to, not mechanical advantage. What we need to calculate? We need to calculate the efficiency. So efficiency is equal to mechanical advantage by velocity ratio. This is 2 by 2. With this it is 1 or 100%. Now children, before combining with a single fixed pulley, after combining with a single fixed pulley, you think, is there any change? No change. Mechanical advantage is 2, velocity ratio is 2, efficiency is 1 only. Means this combination also can act like a force multiplier. Then you may get one out. Sir, as nothing is changed, then what is the purpose? What is the use? Think children, for a single movable pulley, we need to apply the effort upward direction. But here, we need to apply effort downward direction. That is a comfort. That is a comfort to us, so that we can easily exert the effort. Okay children, just copy this. And the last topic which we will be discussing is combination of pulleys. But children, why we need to combine the pulleys? Children, as you go on increasing the number of pulleys, the mechanical advantage is increased. When mechanical advantage is increased, you no need to apply the much effort. By applying the less effort only, we can get the more amount of effort with which we can do many works. Okay children, just copy it. So children, under this combination of pulleys, the first category is one single fixed pulley with many mobile pulleys. So let us say, means mobile pulleys should be greater than 1, at least 2, 3, 4, 5, it depends, actually depends on need actually. Okay, let us see children here. So this is the point where we apply the effort. So children, let us say A, B, C. Children, here B and C both are mobile pulleys, A is a fixed pulley. Now children, so here how many strings we use? 2 strings we use. Children, as long as the string is same, the tension developed will be same. But the moment when string is changed, definitely tension developed will be changed. Okay, for that only, as we have here 2 tensions and 2 different strings, so we will use with the T1, T2. Is that clear? Fine. So this will be here, T1 will be acting. This is the T1 and here also T1. So here it will be T2, here it will be T2. Now children, here effort is balanced by T1. It's a clear. Now here load is balanced by these 2 tensions. That is what actually load is equal to 2 T2s. But children, here this T2 is there, you know. This 2 is balanced by this, sorry, this is T1, extremely sorry, yes. This T2, this T2 is balanced with these 2 tensions, T1, T1. That is what T2 is equal to T1 plus T1. So which means what here? T2 is equal to 2 T1. Now this you can substitute here. Then what do we get here? L is equal to 2 into 2 times of T1. This will be L is equal to 4 T1. E is equal to T1. L is equal to 4 T1. Can we make a relation between load and effort? Yes, we can. In the place of T1, you can substitute E. So L is equal to 4 times of E. That is fine. Now let us calculate the mechanical advantage. Children, here mechanical advantage is equal to, we know that it is load by effort. So load is 4 T1, effort is T1. T1 cancel. So here mechanical advantage of this system is 4. Is that clear? Fine. Now we need to calculate the velocity ratio. Velocity ratio is equal to effort displacement by load displacement. Children, for suppose this load is lifted by X, then what will happen? These 2 segments loosen by X, that is pulley B is lifted by 2x. Then what will happen? This will be loosened by 2x, this will be loosened by 2x. So 2x plus 2x will be how much? 4x. Means this effort will come downward by 4x. Okay, fine. So here effort displacement is 4x, load displacement x. X cancel. So here velocity ratio is equal to 4. Obviously, efficiency is going to be 100% as it is the ideal pulley. But she'll try to understand. Now here mechanical advantage, velocity ratio is increased to 4. If you go on increasing the mobile pulleys, the mechanical advantage and velocity ratio go on increasing. But children, every time calculating like this, sometimes due to exam tension, we may get confused. For this, we have a direct formula with which we can get the answer. What is that here? For this case only, children, mechanical advantage is equal to 2 power n, even velocity ratio also here 2 power n only. What is n here? N is, children, here number of movable pulleys. That's it. So by seeing the diagram only, we can get the mechanical advantage velocity ratio value. For suppose in this case, how many movable pulleys are there? 1, 2. Let us try. So that will 2 power 2 is 4. Here also 2 power 2 is 4. That's it. Same thing we got, right? Now after saying this, you think, oh my God, sir, what is this? But then why you explain all these things? Children, we should understand the concept. Then you can go for these tricks actually. If it is asked for 1 mark question, children, you better go for this. Nothing is wrong. You will get the full marks. Okay, na? So this is what actually type of combination of pulleys where one single fixed pulley is with many mobile pulleys. Now we discuss a block and tackle system. Okay, fine. Just copy this. Block and tackle. Children, what is a block? Children, just think about the gated community where many apartments are there. So there we have block A, block B, block C. We have like a blocks. Their block means what? It's a combination of flats actually. Combination of means we won't mix actually. One flat like this. This is like one block. We can say that actually, where many blocks are placed together actually. Flats are placed together. We can use a block. Here blocks means what here? Pulleys are arranged into in one metallic frame. It is arranged. What is a block, children? Here a block is a metallic frame where pulleys are arranged. Pulleys are arranged. Is that clear? So we need to learn few points. First let us see the diagram, then we can go for what are some important points related to the block and tackle. Yes, so the tension. Children, look at here. So here, okay, forget about here, two diagrams I made actually. Okay, that you leave it. What is this? What is this? We'll come to that point actually. First of all, children, what is a block means? The metallic frame in which pulleys are arranged. See, look at here is one block. Here is one block. Here is one block. Here is one block actually. Here we have two types of block. One is the upper block. Next one is the lower block. Children, upper block is fixed, but lower block is, this is movable. Lower block will be movable. Children, here as we are arranging only here, okay, that's fine. Then what is a tackle? So tackle is a string which connects the pulleys in a different blocks. Tackle is a string which connects the pulleys in a different blocks. Is that clear? Fine, children. And one more important thing, here we are using the ideal string only, and that too we are using only one single string, so that you can see tensions are same in all parts, all segments of the string. Tensions are same. Is that clear? Fine, children. And here we have, for example, children, here as I said that there are two types of blocks, upper block and lower block. Here one important point we need to understand. If there are even number of pulleys, upper block will have, lower block will have same number of pulleys. Upper block and lower block will have same number of pulleys. If 8 pulleys, 4, 4, 6 pulleys, 3, 3. If then what will happen, upper block will have an extra pulley than lower block. If 3 pulleys means 2, 1, 5 pulleys, 3, 2, 7 pulleys, 4, 3. Like that it will be there. Clear? Fine. Now let us calculate the mechanical advantage, Velas ratio. Let us calculate. And here one more important thing, children, here. So the simple thing is that, so Velas ratio, in this case Velas ratio is 3. Here in this case Velas ratio is 4. So with you make it a note, sir, without calculating how can you tell? Yes. So here Velas ratio is what actually? Total number of pulleys. Total number of pulleys. Okay, total number of pulleys. That's what in exam also directly they will ask you a question. Draw the block and tackle system with a Velas ratio 4, Velas ratio 3. Velas ratio 3 means you should take a 3 pulleys. Velas ratio 4 means you should take a 4 pulleys. Clear? Fine, children. So let us come to this case actually. Here effort is balanced with a tension T. Fine only. But children, load direction is very important. It is always downward direction. Tension is always upward direction here. In this case actually. Okay, fine. And here this load is balanced with these 3 segments, means these 3 segments of the string are supporting the load, which means what? Load is equal to 3T. So mechanical advantage is equal to load by effort. This is 3T by T. So mechanical advantage is equal to 3 for this system. Okay, now let us calculate for this actually. For this, children, if you can see here, effort is equal to, effort is balanced by tension, okay, but load is balanced by the number of segments of the string, that is 1, 2, 3, 4. In this, what are the 4 tensions developed in these 4 segments will balance the load. Clear? Blindly, children, here how many segments will be there? 4 are there. It's a 4T. L is equal to 40. You can remember like that also. So load is equal to 4T. So now mechanical advantage is equal to load by effort. This will be 4T by T. So here mechanical advantage is equal to 4 we are going to get. This is 4. Am I clear? So this how, see, as we are increasing the number of pulleys, mechanical advantage is increased. So here what is the efficiency? So Velas ratio is 3, mechanical is 3. Efficiency is 100%. Here also mechanical advantage is 4, Velas ratio is 4, efficiency 100, because these are ideal pulleys. And one more question we can expect examination point of view. So in this case, let us see. In this case, for example, children, if effort is displaced by 12 centimeters, if effort is displaced by 12 centimeters, what will means by what height this load is raised? Means effort load displacement they will ask. load displacement they will ask. Means here effort displacement is given, they will ask load displacement. How can we calculate, children? Yes, we have formulae. Velocity ratio is equal to effort displacement by load displacement. Velocity ratio is what? Nothing but the number of pulleys, total number of pulleys. It is 4 is equal to 12 by dl. So dl is equal to 3 centimeters. This is how we can expect the numericals. Is that, children? Fine. So this is almost all important topics which we discussed and covered. Okay, children. So again I'm telling you, children, as usual, first read the textbook, try to make your own notes, then what will happen, then come back to the videos, then you can watch, so that what will happen, you will have a nice revision. Okay, children, thank you so much, all the very best.